Hello everyone, my name is Andrew. Today we continue learning Python and today we'll talk about transactions in SQL. So let's start. Well, transactions not only in SQL but transactions in general. Why do we need them, how do they work, and what are those? So here I have a function called createUser. It accepts username as a parameter and it does two things. First of all, it creates a user, saves it in the database, and then it creates our user balance. So imagine that we have a program where we have two separate tables or two separate entities for user and user balance. First of all, we need to create a user, and then we need to add a record in a table or an object somewhere that will be connected to that user ID, and we're going to save it as well. So what is the problem with that code? We can go to that diagram, and that is server here, and that is basically our current program. So we have our actor, he or she sends a request to the server, and server uses our database to create user and user balance. But the problem is that our user and user balance are separate from each other. So user here, user, and user balance, like that. So they are separate from each other. What do I mean by that? We have two separate queries to our database. So user here, so user saved here, and the user balance here. If we are talking about ORM, those queries are inserts. So we have insert for our user here and insert for our user balance on the 7th line. Why is it bad? Imagine that our user was created successfully. So everything is alright with our user. But user balance, through an error. So user was created, but then our database was turned off, or our database broke for some reason, and our user balance was not created. What does that mean? That means that our database is inconsistent in that case. So we have our user, but we need user and user balance. So as you can see, that connection, that foreign key, if we may say, goes to nowhere. And why is it bad? Because when our database is inconsistent, we can't really work with our data. So we want our data to be consistent. We want our data to follow some sort of rules. In our case, the rule is that our user has user balance. So our user record has a corresponding user balance in some separate table. And if one of those records is not present in our database, it's inconsistent. So user balance does not have user. So why do we need that user balance in the first place if we don't have user for it? User balance or user does not have user balance. Kind of like that. So we want our database to be consistent, but there is a problem. We have two separate queries. So that query and that one. If we're talking about one query, so if we're only talking about user, it's easy to create that user. So you're basically saying insert user to our database or db.create or something like that. And your user is being created. That's it. But if you have two separate queries, you need to use transactions. And basically transaction is a mechanism that allows you to group many queries together. So kind of like that. Our transaction will group them together. Let me do back like that. And we're gonna treat both of those queries as one big query. So user creation query and user balance query are going to be treated as one. And transactions are really, really important because they allow us to keep our database consistent, aside from other things. So let me talk about ACID transactions for now. ACID. And you understand why are they so important. But in 99% of the cases, we're using transactions in order to remove all the changes if something goes wrong. So how does it work? If our user creation was successful, but our user balance was not successful, then we roll back our changes. So we delete all the changes that we did before. In our case, we're going to delete our user and throw an error. But if something is not alright with the user, user balance is not going to be created as well. So if user threw an error, user balance is not created. If something is not alright, all of the changes roll back. We undo all of the changes. That's the rule. And if everything is alright, so if everything is alright, each query was executed successfully, then of course our program, our transaction is valid, and we apply changes to the database. So what is ACID? ACID are rules that allow your transaction to be even more secure. So all of them stand for separate words. So let's start with A. A is atomicity. So atomicity basically means that your transaction and each query in that transaction is treated as a whole. You either apply everything or you apply nothing. And in our case, it's really, really important, because if we apply only user, so if only user insert query was applied, then our user balance will not exist and our database is inconsistent. So we need to treat the transaction and every query inside of the transaction as one big entity. So we either apply everything or we don't apply nothing. And we do that in order to, once again, keep everything consistent. We want to keep everything consistent because that's how our program works. That's the rules of our database, of our business logic, of everything. So Atomicity, once again, is if everything is executed, we're going to apply those changes. But if we have an error in one of the queries inside of the transaction, everything is going to be rolled back, kind of like that. Then C. C stands for consistency. So consistency is basically the same idea as I told you before. So consistency. Our database state should be consistent. But there is a big idea that when you're talking about consistency in transactions, you need to understand that you will not impose any business rules on your data. So the only rules that are going to be checked and the only consistency that you're going to be having in your database is the consistency in terms of the checks, constraints inside of the database. So imagine that we're talking about SQL or relational databases. Our user and user balance are connected together using a foreign key. Consistency in asset is going to check that user and the user balance are related using that foreign key, and there are no problems with that. C for consistency in asset is going to check that our username has 3 or more letters if we supply check constraints to that username. So only the constraints inside of the database are going to be checked. If I just impose that rule inside of my business, inside of my server, inside of my application, so if I only say that my user and user balance are connected, but I do not impose any foreign keys, I do not impose any constraints inside of the database itself, then of course my database is not going to check on that, because the database doesn't know what are my business rules. It only knows the constraints within itself. But of course, if you're talking about transactions, you don't forget about A. So atomicity is also important. So if you don't have a foreign key, that doesn't mean that your user balance will not be created or that user will not be created. That just means that database will not check that everything is alright within our user and user balance. Because if they're not connected, if they're not connected, they're treated as separate entities, and that is consistent. So everything is alright with that. So basically, consistency means that your data is consistent at the end of the transaction. Then isolation. And isolation is really, really important because there are some things in isolation that do not work as intended, because isolation basically means that your transaction should not be interfered by any other transaction. So if I execute 2 inserts in my transaction, another transaction that is running concurrently with that one should not interfere its result. And it may happen if we work on the same data. So if I work on the same record in the database, that interference may happen. And there are some anomalies in terms of isolation, but I'm not going to talk about them today because it's going to take like 30 or 40 minutes if I'm going to do that. But isolation is really important. So that basically means that your transaction should not be interfered by any other transaction. Kind of like that. And D stands for durability. So durability basically says that your transaction, whenever you receive that your transaction was successfully completed or completed successfully, you're gonna be sure that your database supplied all the changes. So your database changed everything and saved everything that it needed to. So basically, when I execute my transaction and receive OK or something like that, I'm gonna know that database changes were applied, kind of like that. So once again, A stands for atomicity, so our transaction is treated as a whole. C stands for consistency, our data is consistent at the end of the transaction. I is isolation, other transactions cannot interfere our transaction. And D is durability. So durability is that our data, if we receive that everything, if we receive a status that everything is okay, then we are sure that our changes were applied to the database. Kind of like that. So ACID is really, really important. Of course, not all the transactions in all the databases are ACID, but if you work with relational databases, so SQL, PostgreSQL, SQL Server, MSSQL, I don't know, MySQL, and Oracle, stuff like that, then all your transactions are ACID. But of course, in other places, we may not use ACID transactions, but the idea is practically the same. So we treat many queries as one big query, and we can roll back all the changes whenever we need to. And it's really important because if you don't have a transaction, you are going to need to roll back your changes manually. And it's going to be a mess, so always use transactions whenever you're working with your queries. And to be honest, each query itself is a transaction. So when you're just saying insert something into something, that is a transaction. It's just a transaction consisting of one query, but still it's a separate transaction. Kind of like that. So that's basically it about transactions. Also, I want to add that you may use transactions in order to achieve various tasks, not only inserting your data to be consistent, that your separate queries are treated as one big query, but you also may use transactions in order to in order to achieve some tasks when you need to make sure that everything is alright. So for example, if we're talking about event-driven systems, we have a system where we send events in order to notify that something was changed in our application. So for example, our user was created. So user created, kind of like that. For those events, we will typically use something like AMQP, Kafka, or something else. So some sort of a messaging system. And it may happen that our messaging system will break down. So imagine that we have our server, so our messaging system. I'm just going to write AMQP, kind of like that. And if you have never worked with AMQP, think of Celery in Django. So basically the same, Redis Celery in Django. That's how it works. So we create our user. Our database applies the changes that our user object was created. So we basically create our new user. So user here. And then our server sends an event to our MQP. And that MQP may, some consumers, so for example, our analytics may be connected to that AMQP or something else. So some other programs are connected to AMQP. And imagine that we need to send those events because our system depends on those. So if something happens to that event, it's going to be really, really bad. So we need that event to be in analytics. And there is a problem that if we are talking about normal applications, we can send our user query, so we can create our user. But then when we create our user created event in our application and we're sending it to MQP, something like that may happen. So our MQP will not be online in that moment. And our user created will give us an error and everything will break down. But the problem is that we have not yet sent our user created, but our user was created. And if our MQP is down for a really long time, then our user created will just disappear. And that's not what we want, because we want our analytics to be as transparent as possible, not saying some invalid data or not supplying some invalid data from our system. And what we can do in that case is add user and user created as one big transaction and save our events inside of the database, and then somewhere in our server, somewhere in a separate task, send those events, getting them from the database and sending them to MQP once more. So if we use that pattern is called transaction outbox, and if we use the transaction outbox, we're basically saying that we can save events and results of those events in the database. And after that, we can get those events in a separate process or in our server process, whatever you like, and send those events to our MQP. But those are stored in the database. And if that's the case, what we can do is ensure that our event is reflected in the database. And at some point in the future, we're going to send it. So if MQP is down for 10 days, that doesn't matter because our transaction created both user and user created. And when our MQP is going to be online, user created is gonna be sent. Kind of like that. So transactions are really, really important, and if you want your data to be consistent, then of course use them. So that's kind of it. Thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, and bye bye.